the button. It says we are live, and then there's usually like a 30-second delay or something before it shows up on YouTube. So I always like to make sure that it actually shows up and that we're streaming.
Nice.
Hello, anyone watching. You can let us know. Can you hear us? Can you see us? You can type in the chat, say hello. It's always really fun to see where people are watching from. Cool, and we are live. Hello, everyone. I think there's a couple people watching on YouTube, and some people will probably be joining in on LinkedIn here. And again, if anyone is joining in, they want to put in the chat. Again, I always think it's really fun to see like where people are watching from. If you want to also put in the chat why you're interested in Edge AI or if you've worked in it before, that's also really fun to hear as well. And we're going to wait just a few seconds before we get going. I'm also going to have a sip of tea. Or yours is coffee, right?
Yeah, mine's coffee. It's morning over here, by the way. I'm in Kuala Lumpur. It's 12 p.m. here now.
Oh, it's 12 p.m.
Yeah.
Gotcha. So you're 16 hours ahead, I guess.
Oh, yeah.
Right? I think because it's 9 p.m. here where I am.
I see. Nice.
Yeah. So I'm glad we could figure out the time though. And I'm a little bit of a night owl anyway, so I was like, that sounds great to me. I'd rather talk to someone at 9 p.m. than 9 a.m. my time.
Yep, good timing for me too here.
Awesome. All right, so I'll just get started with introductions real quick while people are still joining in. My name is Sage Elliott. I'll be the host for today's Robust and Responsible AI event. If you've never been to one of our events before or watched our recording, we're a community of AI and machine learning practitioners, researchers, designers, and much more. You can think of this as kind of a live podcast. I'll be interviewing guests starting with a specific topic, and then we might have some time left at the end for questions, and feel free to ask questions as we go. Hopefully we'll see them in the chat. But I always encourage you just to chat throughout the conversation, even if we're not quite looking at it, and connect with others, either in the live chat, or we also have a Slack channel. So if you're watching the recording or this live, you can join the Slack channel. The link is in the description below. I think most of the things that we'll probably bring up, the links are already in the description. And I always say, if you want to come on for an event like this, let me know in the Slack or on LinkedIn. I always love having people on and talking about some sort of topic that they're passionate about. And today, our guest is Dickson with ZenML, and we're going to be talking about the applications of Edge AI. Before we talk about the applications, Dickson, could you introduce yourself and give us a little bit of your background?
All right, thank you, Sage, for having me over here. I'm so happy to be on this show. And my name is Dickson, and I am currently a developer advocate at ZenML. And prior to this, I was actually an academic. I was teaching in a local university over here. It's called Malaysia's National Energy University. So they deal a lot with energy, like electricity, demand, supply stuff. And it's a university. And during my time as an academic, I teach microcontrollers, microprocessors, digital logic, like circuit related stuff. And my passion at that time happened to be like AI. So that was the point where I realized, oh, there's AI, there's the hardware, there's the software stuff, and there's the hardware stuff which I'm teaching. And that's how I got into what we're talking about today, which is Edge AI and its applications. And during my time as an academic as well, I had a chance to do like a PhD in using AI and specifically Edge AI to predict the amount of battery charge in an electric vehicle. So the more I see what's going on in the AI world, like the more I'm interested. And so last few months, I decided that okay, I'm just gonna make a transition. I'm going to take a leap of faith and going out from the academics world. And right now I am a developer advocate at ZenML.
That's super exciting.
Right.
I know we'll probably get a little bit into this later, but you mentioned like doing that project on battery life prediction. Was that one of your favorite projects that you worked on in university?
Well, to be honest, no.
Yeah,
My
what was one of your favorites?
Yeah, I mean, I've always been like a computer vision guy, so I like seeing things in action. I like seeing the animations. I like seeing bounding boxes, mass and detection. So that's my stuff. And for that, I also contributed to like an open source library just to spend my time over there. And the battery stuff and using deep learning with battery was because I had like a good supervisor over here with some good amount of resources on that. And I thought, okay, so why not try to bring this world of AI, deep learning into the world of battery and life prediction and charge estimation and stuff like that.
That's
But
awesome.
yeah, I'm now totally interested in both now.
That's super cool, and I totally relate with the computer vision stuff because we were on a call together a while ago, and I think we had a lot of similarities in our background and what we like working on. And there is something so nice about creating a model that has just beautiful bounding boxes and mask segmentation output and is very visual, which I love
Right.
looking at. And yeah, you can create amazing demos, which I've seen you share on LinkedIn as well. Computer vision stuff is just awesome to look at, I feel like, and I know we're not alone in that.
Yep, absolutely.
Awesome. So before we get into some of the other applications of Edge AI, could you describe maybe what is Edge AI for people who don't know, and like, yeah, what does it mean to run AI on the edge?
Right. So at the basic idea of edge AI is that you're putting that AI very close to where the user is or a data is. So now imagine like you're unlocking a phone unlocking an iPhone maybe, right? So there is like some kind of a model inside of the phone that detects the face and verifies if that's you, and then decides to unlock the phone. So that is an example of what edge AI is. The model and the user or the data, they are closer together. Now instead of like the opposite of that is like a server base. So in a server base, what happens is that the computation or is done not at the device that the user is holding maybe, but it's in some kind of a remote server. So you got to send some kind of data to the server, and the server got to respond to you in some way. So that is the difference between what edge AI and a server based one.
Right. And I think just like you said, it's really good to think about you're bringing AI, like the actual models itself, very close or closer to where the data collection is usually happening. So like you said, on your phone, you're not taking a picture on your phone to unlock it, and like it's not taking a picture and sending that somewhere waiting for a response. It's actually doing it on device, which means usually it can happen very fast, and you're also not like if you, in that case of computer vision, it can be somewhat costly or slow potentially to send images back and forth to a server to get a prediction.
Absolutely.
Yeah. So what are so I we already mentioned a couple in the description of what edge AI is, but what are some of the reasons to run AI on the edge versus like the other solution you talked about? So let's say like we don't want to send that image up to the server or send our data to servers to get predictions.
Yeah, I think like you just mentioned one of the big ones just now. Like you don't want to unlock your phone and wait for a few seconds for that picture to go to somewhere and verify if it's you, and then the phone unlocks, right? So I think one of the crucial reasons to have edge AI is the latency factor. So in many applications nowadays, you want things to run in like real time. Like unlocking the phone is one of it, but think about some applications that's more critical, like for example like self-driving cars, right? So the model is supposed to detect if there's a car ahead of you or there's a pedestrian ahead of you, and you want the response to be as real time as possible. Like any milliseconds delay, like it could cause like potential accidents or major catastrophe to it. So latency, that is one huge reason to have edge AI. And of course, when you have the model on the edge, like that also means that, let's say the car that your self-driving car goes to some kind of a remote location, and you still have internet, but it's like intermittent, or maybe in some cases you don't even have the internet connection at all. So in the edge case, like that car might still survive that ordeal of not having internet connection. But imagine if your car is connected to some kind of a server and it needs that server to churn out the prediction, then I think we will never find that car again.
Right.
Yeah,
Yeah, so I think it's like speed is a big one, like you were
latency.
mentioning. So it's almost like
Yeah,
closer to real time,
yeah,
and I guess like almost robustness, like you're not relying on that internet connection. So we'll talk about some other industries probably that have intermittent internet connection, and then we mentioned too, if you're sending data that is very big, like images, it could also be cost reduction. That could be really pricey to send up data,
right.
especially like if you're in an industry like agriculture or something where you might not have access to like a Wi-Fi access point or a landline, and you'd have to use cellular data. It can be very expensive to send up images back and forth. And then
Right.
one thing too, I think that we didn't mention is privacy is one as well. So like if you're not sending data out anywhere, there's some industries that are pretty stringent on where data can
Yeah,
be transferred
yeah.
to, and so privacy is a big one too. Like you're essentially keeping it in house.
Yeah, absolutely. I think privacy is a big one that you're raising over there. I think it's a big one because like some things like medical information, personal identifier data, and I mean some companies they are not comfortable knowing that data will leave their premise going to somewhere else and being processed and being sent back to them, and that is one thing. And the other thing is also on the law. There's more and more now laws coming out regulating this data privacy. For example, I found one that in California, I think they have like a California Consumer Privacy Act that says you can collect the data, but uh, how you use the data is another story. So if you can collect the data, doesn't mean you can use the data to train a model. Doesn't mean you can reuse the same data to either do some kind of other purpose with the data unless it is stated that way. And yep, and user consent is another thing, and not everyone will consent their data being collected in that way. And yep, privacy laws.
Yeah. And things like let's talk about, I guess, some of the, like, what are some of the applications of edge AI? So like I think this goes into like the ties into those things like privacy. Like healthcare is one, right? Like you can be running um, models on an edge device in some sort of healthcare setting, and you're not transmitting that data out. So for example, if you're using it in radiology, and potentially on an edge device, it could also be potentially in a in-house server or something. But yeah, like you're not in that case, you're not transmitting pictures or images from of an X-ray from a patient anywhere. It's actually just giving you a prediction from like essentially right when you're taking it.
Right.
What are some of the other areas or fields that you have seen a lot of kind of adoption of edge AI?
Yeah, so we talk about self-driving cars and we talk about healthcare, and the one area that I'm very familiar with is energy forecasting.
Oh, interesting.
So yeah, energy forecasting, which is yeah, my the university I was at does a lot of this energy related stuff. So in energy forecasting, I think like in many industries also, it's very critical to ensure that the power supply is consistent, it's continuous. And to do that, we got to make sure that the supply and the demand of the power supply is always balanced. So you need to have an equal amount of demand to meet equal amount of a supply. And the moment when the demand exceeds the supply, that's when trouble happens. And in that case, like in very extreme situation, the grid can be unstable, and in extreme cases, it results in failure of the grid, and people lose power, and stuff like that can happen. So this is where I see that it's a good potential of application of edge AI. And what so this edge AI, they are devices that scattered throughout the grid, right? And they collect data and they can process data on the edge. And what they can do is that they can provide like an accurate, maybe not accurate, accurate is like a very hard word to say, like a good enough estimate, good enough forecast of what is going to happen, like maybe 30 minutes, 1 hour ahead, so that with that kind of information, they can either ramp up or and down the supply to meet the actual demands. And that's I see there's a big potential applications over there, and especially with newer things like renewable energy. So, and these energy forecasting models could be super helpful, because some of these renewable energy resources, they are not like consistently available. For example, like wind, you don't have wind all the time 24 hours, so you kind of need to know what's ahead, and then you need to prepare for that. And like solar energy, for example, it's not like you have the sun all the time throughout all the year in some places. So a good forecasting model, I think, could do a lot in this area.
That's awesome. That's one use case I'm not very familiar with, and I hadn't really even thought about. That's really cool to hear. Like, I love hearing use cases like that. That I'm assuming I'm not alone, and like I haven't thought about that before. And I just love hearing these really cool AI use cases that are used in all these different fields that you don't normally associate with like machine learning and AI. That's a new one for me, for the edge applications. It's really cool. Some other ones that I was just going to bring up too is, and I think we had talked previously a little bit about manufacturing applications. That's also one where, depending on the factories and stuff, you won't always have a solid internet connection, and in a lot of those cases, you're also using computer vision to do some sort of quality assurance type evaluation, and so you don't want to wait, right, pinging the image all the way up and getting prediction. So that's one, like, that's actually how I got into machine learning and computer vision, was creating a edge device with a computer vision model for a manufacturing situation, which is really cool.
Nice.
One other application I just want to mention real quick that I was thinking about when I was planning this talk with you was VR and AR, because now you have computer vision models running on headsets that are doing hand tracking and object tracking and all sorts of stuff. And I think that's a really good application of an edge computer vision model running on a device.
Yep, absolutely.
And it has to be fast, otherwise you might get motion sick.
Yeah.
So there's a really cool applications that we've talked about. What are some of the challenges of running AI on the edge? I know you've done a lot of really cool projects and work about optimizing models to run on edge devices. Could you talk a little bit about that?
Yeah, so there are a couple of challenges. So I'm going to talk about maybe a few of them over here. Yeah, the one that you're talking about is on the model and the algorithm. And so the thing with a lot of this AI model is that by default, they run very well on GPUs, or at least on a specialized hardware. So for example, like the recent one, Stable Diffusion, I was playing around with it and I was trying to run on my machine. And then like I went through the repo, and then it says, you need like a GPU with 10 GB of VRAM or something like that. And I thought, oh, okay, good thing I have one myself, but I was thinking, oh, it means that this model, not everyone can run this model. So you need to kind of have like a GPU or specialized hardware to run this. So one of the many breakthroughs, or one of the many research area with a lot of works right now, is how do we make this kind of big sophisticated model to be accessible to everyone else. And that means that is there a way for us to not use a GPU and still run this model? And that is the area of the research. And in this area, there are like three prominent ways people are doing that nowadays. And one is called quantization, and the other two, they're called pruning and model distillation. So with these three methods, we are now able to put like big models and simplify it to a certain extent. And now you can run this model even on a conventional CPU that anyone might own at home. And there's also a lot of works in right now in advancing the hardware itself. So more and more powerful CPUs, of course, more and more powerful ARM. I think it's a lot more ARM. ARM is a lot more better now these days, and they can really run some of these models already. Yep. And the work that I was doing, and I wrote them in my blog post, they are quantization. So quantization essentially means you take a model and then you simplify the storage format of the parameters so that they're not as detailed. So by default, they're stored in like a float 64 storage format. So that means there's a lot of numbers over there. So the idea is, what if you can simplify that? Instead of storing so many floating point numbers, what if you just store like a simpler version? We call that int8 or integer 8 format. And just by doing that alone, that makes the model runs a lot faster. In some cases, like 2, 3, 4 times faster. It's possible to do that. And just using quantization alone, it's possible now to run like sophisticated computer vision model or language model on a 4-core CPU, on an 8-core CPU. And this is huge and it's game changer because now anyone without a GPU can run it.
Yeah,
Yeah, and
that's awesome.
the other thing, oh, sorry.
Oh no, sorry, I cut you off. I was just saying
Yeah,
that's awesome.
yeah. The other thing, yeah, apart from quantization, we can also do something we call pruning, which is eliminating certain parameters from the network. So maybe in the beginning, the model is like huge because there's a lot of data that's stored in the model in forms of weights. And the thing is, not all of these weights are useful in making a prediction. So in pruning, what we do is that we try to eliminate some of these weights, or we call parameters, that's not in use, and we can prune it to a certain extent to a point that the model is like small enough to be run on an edge device. That's another method. And the last one I think is very it's gaining popularity now, is called knowledge distillation. So essentially this means that we can take the knowledge from a large model and then transfer it to a small model with similar performance or maybe no degradation. And with that small model, now it's possible to put it on a phone or any edge device. That's yeah.
That's awesome. It's kind of like maybe I'm oversimplifying, but it's a little bit like transfer learning, but you're going from one model to a different model, I guess.
A smaller one.
Yeah, that's pretty interesting. And with most of these, like the quantization and pruning, sometimes you might get a little bit less of accuracy or a little bit of degradation of the model potentially. But I think from what I've seen with a lot of the use cases, it's often not as much as you might think it is. And I'm sure it varies on your model, but it's very impressive about now how, like you were saying, you can do quantization on a model and essentially, compress it to be way smaller than it used to be. And you might lose like a little bit of like a couple points of accuracy if that's what you're measuring. But it's totally worth it to run on an edge device at a really increased frame rate if you're doing computer vision or speed, right?
Yep, absolutely. It's just the usual trade-off. Do you want faster model or do you want accurate model? So and you can control like how much degradation you want to a certain extent.
Right. And it is like you're saying, it's often a trade-off. So if you're doing a edge computer vision model, you don't always need it to be running at 30 frames per second. You might be fine with it doing like 1 frame per second or something, or even less than that potentially. If you're just trying to detect like every several minutes or an hour, you want to see if something's happening and run some sort of classification model, you don't always need the fastest speed there.
True.
On the topic of hardware and putting models on hardware, do you have a favorite piece of kind of edge hardware? If people like have never put a model on an edge device before, what would you suggest they get hardware wise?
Well, my go-to hardware has always been a Raspberry Pi. I think like we talked about it also like in the past. So partly because it's cheap and it's available and it's anyone can use it. So that's why I usually gravitate to hardwares like this. But if you want even more fancier ones, like you can try like maybe an NVIDIA Jetson, or Google has something they call a Coral TPU, and I think Intel has also their own version of like a neurocompute stick or something. I've used that in the past, and obviously these are specialized hardware, and they run much faster than like a Raspberry Pi or a general purpose computer. So if you need to run like something specific, like a high frame rate computer vision model, so if you can get like a compute stick, that would be awesome. But one thing to bear in mind is that you need to check whether or not this hardware actually support the model, because they don't support every model that comes out of that you see on GitHub or something. Yeah, and usually also there are some works that you need to do for that model to end up in that hardware. There's some kind of a pruning, quantization, or there's a few steps that you got to do to get those. But the good thing is that they are super high performance, and I think like with that, I think with the neural compute stick, I think I once ran a model close to like 30 frames per second, and it's just a USB stick, and you can just plug this USB stick to a Raspberry Pi. You can plug it to a computer, and it just costs, I don't know, it's cheaply available.
That yeah, I think it was like called the Movidius or something like that compute stick, if I
Yes.
remember correctly.
Yeah.
And then yeah, Google Coral, and Coral also has a USB version that you can stick into Raspberry Pi. So I
Yeah.
also love Raspberry Pis, and I have way too many sitting around in my home that aren't in use right now. But they got really expensive recently too, because I think there's like the chip shortage or scalpers or something, and they don't feel as cheap as they used to be buying them new. Um,
Yeah.
yeah, Raspberry Pi is really, I feel like, approachable, and like you said, I think one cool thing about it is it might not have as much of a like a GPU or something to run the models on, but it feels easy to get started, and you can run a model on the CPU and go through some of those optimization steps. And then if you want to go a step further, you can get one of those compute sticks that can actually plug into it, and you can go through those steps of getting it to run on a TPU.
Yep. Oh, yes. And on that topic, um, the other thing that's interesting to me nowadays is that putting these models on Android, like on phones, because we all have Androids, like we all have some kind of mobile. So if it's running on Android, then good news. I think there's a lot of libraries right now that you can just build and package it into a small form APK file, and you can just side load it into an Android. Something I was also trying to do myself. So I was working on putting like a YOLO model, object detection on the phone. But yeah, of course, you cannot expect it to have the same kind of a performance compared to like specialized hardware like Movidius or something. But still, it's pretty interesting because on the phone you have like a complete package of sensors over there. You got camera, you got like accelerometer and stuff like that. So all these readings, they are available to you on the phone, so you don't have to get like accessory and then plug it into like a Raspberry Pi, right? You have to do like your own sensor, wiring them together. But yeah, although it's fun to do it, like I really enjoy doing that, to be honest. But if you're looking at something more convenient, yeah, putting models on the phone, they are pretty
Yeah,
interesting.
that's a good point. Phone the putting stuff on the phone is really cool, and most people have a phone, and most of at least like the flagship type phones that I know a lot of people have, they now all have some sort of NPU neural processing unit that can actually run models way
Yes.
better than they could have like 4 years ago. So if you have a phone in the last year or two, chances are you can actually run models at a decent speed on it, which is cool.
Yep.
And then I'll quickly mention as well, Raspberry Pi has the new microcontrollers that just came out like a year ago, and then they
Ah,
have a new um, internet connected one that you can get as well, and they're like $4 or $5. And
yeah.
now this is way harder because you really have to specialize your model to run on a microcontroller. But I know some libraries like TensorFlow specifically, I think they have a MicroPython specific model to like kind of compile a model to go to these really tiny devices. So if you want to try running, some sort of voice command model, or I assume you can do some sort of maybe computer vision, but I'm sure you're going to be very limited in what you could do there. But you could actually do that in an even cheaper device if you wanted.
Nice.
Cool. So we've talked a lot about some really cool applications of Edge AI and your background. Thank you so much for sharing all of those really cool stories and insights. And I want to get into, what are you working on right now? I know you're doing a lot of really cool stuff, and I'd love to hear a little bit more about ZenML, the company you're at.
All right. So at ZenML, what we do is ZenML is a tool that helps people put models into a production. So yeah, this is something I realized when I was doing my PhD, and I've seen like too many models. They end up on research paper, and once the paper is out, and then like we forget about it. It's the ecosystem is like that. And I was talking to my supervisor when I was finishing my PhD program, and I was asking him, so can we like put this model, like, can we move it forward? Can we put it, like the model of this battery prediction model into some kind of a hardware or car and something? But that was the end of my program already, and he said, it's okay, your program has ended, the paper is published, so we move on. So I feel like it's kind of a pity. It's a waste over there. That's a lot of cool models that potentially could change many things, but they end up just on papers on some Jupyter notebooks. So what ZenML is trying to do is that we are a company that tries to facilitate the transition over. So ZenML is a framework, and with this framework, you can pull in many libraries to help put this model to production. And for example, in research, you don't talk a lot about monitoring your ML model while it's running, right? So, and this is in the field of ML ops now. I think it's there's so many ways you can monitor this, but it's not talked about as much. And so ZenML is here to be like a framework where it allows you to use the tools that you like. You can integrate with any framework, with any libraries, open source libraries that you have, to bring what you're comfortable with working. So if you like working with PyTorch and YLogs, and you can do that. Or if you want to switch to other tools, you can also stick to the framework and just swap your tools as you like. And the thing I'm working on in ZenML right now is we're running a competition. And this competition is, it's called Month of MLOps. And so this is a month-long online competition where it's open to everyone, and you don't need to, there's no entry fee, whatever. So the only requirement is you register, and then you pick a problem of your choice, and now choose your own framework, whatever you want, and put it into like a production ready stack. And duration is 4 weeks. It starts October 10th to November 11th. And so there's a lot of reasons to join this. I think some people join to win the prize. Of course, the prizes, they are awesome. But I think the majority of people who join it, from my conversation with them, is that they want to learn what is it like putting this models into production. Because frankly, not many people are very familiar with how to do it, and even few people know how to do it well. And ZenML is here to help with that. And so the link of the competition is on the screen. So do register if you can. Competition, ZenML.io/competition. And if you have any questions, you also feel free to join our Slack.
The link is also in the description, so anyone watching, or if they're watching the recording later, instead of typing out, if you want, you can go into the YouTube description and click that link there.
Yes, and yes, also on the competition, so we've got ourselves some pretty cool judges. So I don't think these people, they need introduction. They are like all over the internet right now. Charles Fry, the guy was from Full Stack Deep Learning. I think if you're in MLOps, like, you must take this course, Full Stack Deep Learning. Super helpful. Anthony Goldblum, co-founder of Kaggle, and Chip Huyen. Yes, I think it's like the one of the top voices in MLOps nowadays, and of course Goku Mohandas. So if you think you got something to show, like, just join us in this competition and let's see.
And it's a great opportunity, like you were saying, if you've never put a model in production before, this is a great excuse to learn how to put a model in production and then use those skills going forward.
Yes, and you've got nothing to lose. Just join, and maybe you learn. Like, I mean, I'm sure there's a lot of learning, and yeah, it's a good opportunity to interact with these judges as well.
And it's pretty open, I think, to kind of any skill level, or is there some stuff that people should maybe know beforehand?
It's open to everyone. So even if you're a beginner, there is like we have like a most promising entrance. So if you're a beginner, don't worry. You have nothing, no experience at all. Don't worry. It's this whole month is the time where you can use to learn about it, actually. So I think we also have this prize for most promising entrance. We have 2 prizes for that. So we will evaluate the project based on maybe how novel or how interesting or how promising this project is. So don't worry if you're a beginner or something.
Awesome.
Yeah. And the last one would be over here, and we'll have like a special launch event so this is going to be about the latest version of ZenML. So there's been a lot of works going on behind the scenes at ZenML, and this is like one of the major rehaul on the ZenML ecosystem. And we're going to have like a special launch next week. It's on October 5th. It's on a Wednesday. And on this day, we are going to showcase some cool new stuff with the latest ZenML. And we're going to talk about the latest dashboard that we have in ZenML, and we're also going to talk about Zen Server, we call it, but essentially it's a tool where people from various places can collaborate in using ZenML together, and it makes the whole experience of putting the MLOps or MLOps text into production like a lot more easier. So if you have the opportunity, do join us in this launch event.
Awesome. And the link to that is also in the description. So if anyone wants to
Yes.
join, they're watching this or they're recording, links to everything that you just mentioned is in the description, and it all sounds really awesome.
Right.
And then, also links to your blog and everything's in the description as well. So you mentioned various projects you've worked on, like all the optimizing models to run. If people want to learn more about that, links to your blog, also your social media. You always post really cool stuff. We were talking about how posting computer vision models and looking at computer vision models is always awesome. So if you want to see more of that, definitely follow Dickson on LinkedIn and Twitter as well.
Right.
One last question before we go, if you still have time. I know we're slightly over our 30 minutes. I don't know if you have a hard stop.
Nope, you go ahead.
What is an AI trend that you're currently really excited about?
The one thing I'm really, really excited about is the rapid pace of research that's ongoing right now. And I think as an academic, this is exciting and both exciting and overwhelming at the same time, because on a weekly basis or monthly basis, you see like breakthrough after breakthrough coming out. And I think the latest one is stable diffusion. And like it's not too far ago that we saw Imagen from Google, and then DALL-E that just came out like not too long ago, and things like this keep coming up, and it's exciting. It's an exciting time to be in AI, in deep learning nowadays with this rapid pace of research. And recently, I also came across this Whisper model by OpenAI, which is also super awesome, but I haven't got the time to play around with it. And the other thing that I'm excited about is in the MLOps field. And nowadays, the field is picking up, and there's a lot of tools nowadays in the MLOps field that aims to do like different things and facilitate users to put their model into production. And yep, and it's as I said just now, as a researcher, it's really frustrating to see models just on paper. And right now, it's changing. And I'm just so excited to see where the entire MLOps field is going right now.
Yeah, it's I forget the stat, but there's always some stat flying around that something like 90% or 90 something percent of models never make it into production, and it is
Yeah.
exciting. Like I also work in the MLOps field, and it is cool just seeing so many tools and libraries pop up around it that make it way more accessible to do things that previously were really hard to do. So just like ZenML, right? Like makes it way easier to tie together different tools and do deployment.
Right.
And also, like
exactly.
you said, all the research too is really exciting because one, it does seem like it comes really fast. Like Dolly was there, and then all of a sudden, everyone has Stable Fusion now. Like I feel like
Yeah.
that was like no time at all. And then also, it's very accessible. So like you can take a Google Colab notebook, take the free GPU time, and actually generate your own images with Stable Diffusion, which I've definitely been doing in the last few days.
Nice.
Awesome. Someone said thank you for coming on and for the event, and they're really excited to learn more about ZenML. Thank you, Cody, for watching. And with that, I know we're a little over our time, so I will wrap things up. I just want to thank you so much again, Dickson, for coming on and spending time with robust and responsible AI. And I'm really excited to work more together and do some other events and content around ZenML.
All right. Looking forward to what you're gonna put up with that too.
And thank you, everyone, for tuning in and or watching the recording later. I'm going to go ahead and end the live broadcast now. So everyone have a good night or good day, depending where you're located.
Bye bye.